Hey guys, so we're going to do 3 problems from the systems review today, numbers 2, 5, and 7. I was going to initially do 1, 5, and 7, but number 1 is actually pretty easy. It might look a little confusing, but what you do to start number 1 is take the negative 4z equals 0 equation, divide by negative 4 on both sides, and you get z equals 0, and then plug 0 in for z in the other 2 equations, and then do like math 1 style elimination method for just x and y. So that one is much easier. This one is actually not too bad either. It's just confusing looking, so I wanted to talk about it. A lot of students will take equations like this and they will rewrite them to be like this one. They would move this to the other side and make it 0x plus y plus z equals negative 3. And then they would rearrange this one to have x, y, z. And then they would put a 0x in front of here, and they would eliminate the same way we've been doing elimination for 3 variables. So they would just rearrange all of this and put zeros in for any variable that was missing. But that's not the most efficient way. Maybe it is in some cases, but I noticed in this problem, equation 1 and equation 3 are both already written in terms of y and z. So that means that somewhere along the way, someone out there, the CUDA overlords, already eliminated x. So I am going to take these 2 equations and work on them. And I'm going to ignore equation 2 for the moment. Okay, so notice that this is set up for substitution method very easily. I could take negative z minus 3 and plug it in for y in the second one. So I'm going to do that. So 6, y is going to become negative z minus 3 plus 5z equals negative 20. Now, we haven't done a lot of substitution methods. Some of you guys might say, I'd rather add z to both sides of the top equation and do elimination method. That's fine too. These problems all have a lot of different ways that are correct. Okay, so negative 6z minus 18 plus 5z equals negative 20. Negative z minus 18 equals negative 20. Add 18. Negative z equals negative 2. Z equals 2. Alright, excellent. So we have z. If you notice, I can go right back up to equation 1 and plug z in to get y. So y equals negative z, so negative 2 minus 3, y equals negative 5. Okay, I'm going to take that answer then and plug it into equation 2, because equation 2 has x, so I can plug in my y and get x. X equals 3 y's plus 20 x equals 5. So for me, I feel like that is a lot less work than making a full system of 3 equations, 3 unknowns, and doing all of that elimination. But if you're not good at spotting that like both of those are y's and z's, and you like to go through the process, if you're like a process person, then absolutely just go for rearranging this so that they're all x, y's, and z's. putting 0x or 0y in anything that's missing, and then follow the notes from the equations with 3 unknowns. Final answer, x, y, z. Okay, moving to number 5 is one of those. So number 5 is just, that's sort of true. It has, it already has one variable eliminated also, but it's definitely set up more for elimination style. 2x minus 2y minus 4z equals 16. 6x minus 4y minus 2z equals 6. Negative 2y minus 2z equals 18. Okay, so again, if you don't like how this looks, please put a 0x here in the front and you do the same process as 3 variables. However, I would like to point out that the equation 3, the bottom equation, doesn't have an x in it, which means, to our advantage, someone out there, again the CUDA overlords, have already eliminated x in that problem. So what I would like to do is be efficient and eliminate x in the top 2, and then we can line it up. So I'm going to go equation 1, equation 2, and notice they're all even. I could reduce, but I'm just going to multiply because that's just as easy. Okay, so taking a look at these, it looks like they're all the same difficulty level to eliminate, but we know we need to do the x's because the equation 3 has y and z left, so we know we need to get rid of this. So I am going to multiply the top equation by negative 3. That will give me a negative 6x and a positive 6x to eliminate. Okay, 2y plus 10z equals negative 42. Okay, so now I have equation 3 here and my new equation, which are both in terms of y and z, and I can line those up. And oh, look at this, it's even better than I thought. Okay, so negative 2y minus 2z equals 18. 2y plus 10z equals negative 42. Okay, eliminate that. I have 8z equals negative 24. Divide by 8. Z equals negative 3. And you guys remember on these CUDA worksheets especially, most of the answers come out pretty nice. So if you get something like 2.978463 here, clearly there's an arithmetic problem somewhere up further in the problem and you need to check and go back and look at that. Okay, so now I have Z. I'm going to take that and plug it into this equation. I could also do this one, it doesn't matter. This one's right here, so I'm going to plug that in to get y. 2y plus 10 times negative 3 equals negative 42. 2y minus 30 equals negative 42. Add 30. Okay, y is -6, and then I am going to plug it back into one of the original equations to get x. I'm just going to do equation 1. I don't think there's any easier one than the other. 2x minus 2y minus 4z equals 16. Okay, great. All right, so final answer, x, y, z. Okay. Last problem we're going to do is number 7, and this is one of the parabola equations from number 90, which is going to end up being just like this, but okay, so I think it would help you guys to see it one more time. 3, 7, 5, 3, and 4, 4. Okay, now I just want to mention the directions say opens up or down and passes through those points. Don't be freaked out by the opens up or down. In Kudo you have the option of doing up or down and right and left, and you guys have not gotten to the right and left yet, so these are just our regular ones. Okay, so first step here, I'm going to label these. And we are going to use the standard form equation. And we're going to plug each one of these in for x and y. Okay, so we're going to start with this one. Y is 7a times 3 squared plus b times 3 plus c. Notice I don't have a squared here. This will become a constant. If you're getting a squared here, that's because you're not putting your parentheses and your squared in the right spot. So you should not have any quadratics when you get to your system. 3 equals a times 5 squared plus b times 5 plus c. And 4 equals a times 4 squared plus b times 4 plus c. Okay, so let's make that look a little nicer. 7 equals 9a plus 3b plus c. 3 equals 25a plus 5b plus c. 4 equals 16a plus 4b plus c. Okay. Equation 1, equation 2, equation 3. And I usually set these up all the same way. 1 and 2 and 1 and 3. Okay. Alright, now on these parabola problems, notice the c's are always just one c, so you don't need to think about what's easiest to eliminate. What you want to do is subtract the entire denominator on each one. And I have 7 minus 3 is 4, 9 minus 25, okay, so easy arithmetic on these, there is no shame lost in checking on your calculator, because the tiny arithmetic errors are what causes the whole problem to be thrown off. Okay, just checking my work. All right. Okay, so now I need to make a decision. Which variable is easier to eliminate, A's or B's? And I think this one's obvious, it's B's. I'm going to multiply the bottom equation by -2. That will give me -2b here and positive 2b here, which are easy to cancel. 4 equals -16a minus 2b. -6 equals positive 14a plus 2b. -2 equals -2a. 1 equals a. Okay, when you get a whole number here, you can rejoice, because that means that you didn't mess up arithmetic somewhere down in the problem. Okay, now I'm going to take A and plug it back in here to get B. Okay, great. B is -10. And then I'm going to plug it back into equation 1. Again, it doesn't matter which one. I usually just choose equation 1 for these because they're usually not any more difficult. 9a plus 3b plus c. Alright, so I have A, B, and C. Now I'm going to write the final equation. So coming back to the y equals ax squared plus bx plus c, I'm going to plug my a, b, and c into here. So I have y equals 1x squared, so I'm just going to write x squared, plus bx plus c. And again, if you guys are on a test or quiz or something, definitely graph this on your graphing calculator and make sure that these 3 points are on your table, just to check your work. Hope that was helpful, guys. Talk to you soon.